Welcome back to Hoochos. Today on Hoochos, I'm going to be releasing a completely 3D printable solution to growing plants in self-watering pots. In this episode, I'm going to be releasing the 3D print, giving you instructions on how to print it, as well as sharing my techniques for mixing media for this system. Hydroponic, as well as amending soil-based media so that you have the appropriate capillary action as well as aeration required in a soil-based wicking pot scenario. Previously on Hoochos, we have explored a bunch of wicking hydroponic systems. Starting with the rain gutter grow systems, I developed the first 3D printable hooch bucket, which would sit over the top of a rain gutter, which was refilled from a float valve with 3D printable ends. Now there were 3D printable parts all throughout the next iterations, including the wick wedge, the grow spike, moving into the Hooch multi-bucket, which was a injection molded version, which made the system scalable and cheap, but also required a bunch of DIY skills to assemble systems until we released the multi-flex channel, and now you have a completely purchasable wicking solution. However, what I haven't actually done is provide you with a fully 3D printable wicking solution. And what I wanted to do with this concept was provide you with a large growing volume as well as a fully 3D printable, except for the float valve, wicking pot solution. So, without further ado, let me introduce you to this. This is the Hooch Pot hydroponic system. I'm running out of names here, guys, so I apologize if it gets hard to search for these things. It's essentially a self-watering pot that is infinitely refillable. Using a float valve in the base, which is protected by the pot itself. Now, there are many benefits to this design, including the fact that there is actually no way of water ingress or any bug ingress around the side. It is almost completely sealed around the edges. The pot itself protects the float valve from light and being tampered with by pets. And if you need to clear out the float valve, you can literally just take the pot off, place it next to the float valve, and you can do all of your maintenance that is required. So this prints in two parts, obviously, and I've designed multiple versions for multiple people's printer scenarios. This here is the version that conforms to the Bamboo Labs 256 by 256 by 230 something bed restrictions, and it also misses out on the Bamboo Labs exclusion area. So this pot is able to be printed support free and pretty much with the standard Bamboo Labs slicer profile. I would actually increase the bed layers to 7 so that the base is solid. It should print completely solid except for the top, which I've made a bit thicker so that it gives it a bit more rigidity, and that will just have a little bit of infill. And just use the same settings for the base. The reason I've made multiple bases, I've omitted the float valve hole in one of the bases so that if you want to move the float valve up and down, you can just take a step drill bit and drill out your own float. This also allows people with smaller bed sizes to scale this 3D print to the size of their printer. Now, one consideration when scaling, make sure your float valve is going to fit, because there is only X amount extra room with the shortest format of float valve. To do this, you would scale the print, and then you would take your measure tool and measure between this face and essentially the line back here, and you will see how much extra room you have to play with. I've also made a secondary version of this pot so that power users that have access to something like maybe the H2D or a larger printer, it just omits these flat sections on the side so you can get a more standard round pot, which will actually stack into itself better than this with the missing sides, if that makes sense. I've also designed lids that fit over the top of the Hooch pot to keep out light and water. Leave comments below in regards to the style of lids that you'd like how many plant spacings, do you want any attachments, any ideas that you can give me, and I'll work on bringing those to life in the next few iterations of this design. The volume on these pots is 8.95 liters, so it's actually quite large because the build volume of the printers we're now working with is quite large. And this is gonna be ample room for pretty much any plant you throw at it. I mean, not trees, maybe trees? It will definitely be ample room for larger fruiting plants like cucurbits, and even your tomatoes and capsicums, which do extremely well in the smaller pot size of the Hooch bucket. So these pots, you can produce one for less than 1 kilo, but I'm gonna give you a real world weight so that you can cost your filament to this pot. Both sections of the pot weigh about 700 grams. So to work out the cost of the pot for you, you just times your filament per kilo cost by 0.7. And my cost is $8.40 for the whole system, which isn't including the float valve, because you're gonna have to add that on. But on the Hydroland website, we're selling them for $3.95. I just checked, we're selling it for $3. So the print time is somewhere between like 12 and 15 hours. If you're running on Ludicrous, you could probably pump it out in about like 7. It's not too massive. You could put your printer on, go to work, and then by the time it's dinner, you'll have a pot, and then you just print your basin overnight. The next day you can be planting your plants. Speaking of planting plants, let's set up some plants, and I'll run through my recommended ratios of hydroponic media as well as potting soil, because this can be used with both hydroponic media and potting soil. You just have to amend the soil in a certain way to allow the water to wick properly. Here we have our 2 options moving forward. You've got hydroponic or soil-based. Now, this has chemical fertilizer in the potting mix, so it will have hydroponic nutrient in the mix, but it's just the most available mix here in Australia, and it is somewhat premium. It's not the best, but it's just ubiquitous. So we are going to amend this for wicking. To amend it, we are going to use a hydroponic grade of cocoa. It's just cheaper than the Bunnings stuff. You can use the Bunnings stuff if you like, but it tends to have a bunch of other salts and other things that just throw off the balance of whatever media you're using it with. So a washed cocoa is ideal, and perlite. In our hydroponic mix, we're going to use a 70-30 mix, and in our soil mix, we're going to use a 20 perlite, 50% premium potting mix, and 30% hydroponic grade of cocoa. So I'm going to mix those up, and then we can put them in our pots. So for the hydroponic grade, we're going to rehydrate the cocoa with hydroponic nutrient. This will fill out all of the cation exchange sites on our cocoa, and it's going to absorb in our nutrient and rehydrate that way, so that once we add our nutrient solution in through the float valve in the bottom of our pots, it's already pre-charged and the plant can immediately start growing. The hydroponic nutrient I'm using for the mix is a Campbell's Diamond White Part A and NitroCal Part B, 1 gram per litre, and balanced to 5.7 pH and 2.4 EC. So that's a good fruiting plant EC and a good pH just in general. So 5.5 to 6.5, anywhere in between. And I found that one of these blocks generally takes about 4 or 5 cans to rehydrate. So you're looking at about 40 or 50 litres. And because we know this expands to about 60 or 70 litres, we're gonna add into this 30 litres of perlite. you can use your hooch pots. It'll be like 3.5 hooch pots. Just remember, none of this has to be exact. The plants aren't counting. I'm just wetting it down so that you don't get the dust and you can work with it. Now I know there's going to be a lot of observant people that will point out the fact that I used to always say 60-40. The reason I used to do 60-40 was to save cocoa, because cocoa was my most expensive input. But now that the cocoa is so cheap, it's at like $9.95 per 70 liters, I'm moving back to the standard that is pretty much across the board in hydroponics, which is 70-30. So that's why I've changed over from 60-40. There's very little difference. I'm just moving back to this standardized ratio. And we should get hydroponic media that looks something like this. All right, now I'm gonna do a potting mix. We are only rehydrating the cocoa brick in our soil-based mix with water. Unless you want, you can actually add in hydroponic nutrient, but I'm gonna be testing the two techniques against each other, so it would be an unfair test, because the hydroponic nutrient that we rehydrate with would add extra nutrients to the potting soil mix. Now for this one, I'm actually going to try and split the cocoa block in half, because I only want to use half the block, because we've got 50 liters of the soil. Close enough's good enough. Over here, come on, come here. The wind's blowing that way. Come here. Sit. Good work. Wear a mask. And our potting mix goes on top. And this is our soil mix. It kind of has a bit darker of a composition than our hydro mix. It's more of like a dark chocolate mix. And now that we've got our mixes, we can fill up our pots, and I'll show you how the saucer refills. When you're filling your pots, press the grow media down into those 2 wick feet. Not too much, but just enough so that it's full of material. I don't usually get my hands dirty on this channel. And we can fill up our hydroponic pot media as well. Okay, so we have our freshly printed bases. We're just gonna screw our float valve to our base with our gasket on the inside. Now, I only have about 1 in 10 prints that isn't waterproof, so I've stopped sealing my prints. However, if your print settings aren't immaculate, you can just waterproof these with a spray gloss paint. Just make sure it's non-toxic and you're good. We're gonna add a hose nipple, obviously. It's just a 1/2 inch BSB hose nipple with a gasket, so there's no other messing around. And you can connect this up to a gravity feed nutrient reservoir like this one, which is refilling all of the float valve trays that I showed you in a previous episode. Or for those people just using a soil-based potting mix that's amended for wicking, you can just connect it straight up to house water pressure. These float valves are made for mains water pressure, and they will work absolutely fine. We turn that on, and that will fill up almost immediately. So what we actually want to do here is we want to adjust our float valve, because the top of this saucer is the maximum room that it has. So you want it to be filling to below the top of this saucer, like so. Just tip that out. Adjust the float so that you've got the lowest level possible, because the higher the water level, the more anoxic zone in the pot. So you don't want this water level being all the way up to the top. You want it as low as possible without being below the actual pot being in there. But that's really not an issue with this system, as you'll see when we put this pot in. Because I've made the holes at the very bottom of the pot, it means that even if you have a very small water level, it will still wick up. So this is what it looks like. You're probably losing about a 1/2 liter of growing area in an anoxic zone, but that's absolutely fine. And now all that's left to do is plant out our plants and we can see how they grow. But that is for a future episode of Hoochos. So make sure you're subscribed, and I hope you enjoyed this episode of Hoochos. As usual, the 3D prints are all available on my Patreon. Happy hydroponicking, happy soil growing, and I will see you next time on Hoochos. I don't think I'm ever gonna get the dirt from beneath my nails. Ugh.